All right, guys, happy Thursday. It's Miss Lastly and Miss Markert, and we are doing day number 24, running through a quick review of your fundamental principle of counting and permutations and combinations. Yeah, should be a pretty fast day.
Yep, so we're just gonna go over those really quick. Again, just like we have done the rest of the week, we're hitting the highlights. So if you want more of a review, feel free to go back and look at the notes. That being said, let's just jump on in. So we started off this week with the fundamental principle of counting. Not this week, but the whatever. Fundamental principle of counting. So let's just go over that really quick. So if you have an event E1 and it can happen M1 different ways, and then we have event E2 and it can happen M2 different ways, then the number of ways that this can happen is multiplying those two m's together. So number of ways it can happen. Ooh. Subscript M2, but that's okay. Just like that. This one was pretty straightforward. I don't think you guys had a ton of problems with this one. It was pretty straightforward. Remember, this one is something like the sandwich example that we had where you could pick from like 5 different sandwiches, 2 different desserts, and then you multiply those together, and then that's how many different combinations you can have of sandwiches versus desserts. So if you were to have 5 sandwiches and then you could combine them with 2 different desserts, you would have 5 times 2, and it could happen 10 different ways. So yeah, I don't think this one was too bad for you guys, but there's a quick little review of that one. Okay, so the next thing we talked about was permutations. And remember, this is just an arrangement of n different objects. And the big thing with this one is that order matters. Arrangement objects. And order matters. So for this one, order matters. And that's how you tell the difference between your permutations and your combinations. So if you care about who's coming in first, second, third, then you're going to use a permutation. If you just want to know, say, how many different ways can you have combinations of who comes in first, second, or third, then you're going to use a combination. But for this one, order matters. So just remember that when you're taking your checkpoint. Okay, so then we also had a couple different ways to do permutations. We had permutations of n elements taken r at a time. And your formula for this one is NPR. And it looks very similar to your combination formula, except you don't have the r factorial out on the bottom there by itself. Remember that n is the number of objects that you have, and r is the number of objects taken out. And on your calculator, this is math, prob, and then you want number 2. Remember, it works the same way as your combination. So if you have an old calculator, put n in first to go through those steps, and then put in r. If you have a newer calculator, it's going to pop up with nice boxes for you to just fill in. But yeah. Okay, and then we have distinguishable permutations. So this was used when we had like words and we wanted to know how many distinguishable ways we could redo the words. So things like banana, because remember, if you switch just, if you have banana, if you were to switch this A and this A, it would still say banana. So it would be something like switching that first A and the first B, that would be a distinguishable permutation. And our formula for this one is n factorial over n1 factorial, n2 factorial, and k factorial. Remember, the top here is the total number of things that you have. And then the bottom, you're just dividing off the doubles. So here we would be dividing off 3 factorial and 2 factorial because we have 3 A's and 2 N's. So here you're just dividing off the doubles or triples or whatever, duplicates or whatever. Repeats, we'll go with repeats. Cool. Okay, and then last but not least, we have combinations. And here, again, it's just an arrangement of n objects, but here, order does not matter. This was things like, what was one of our examples? Off the top of my head, I can't think. Oh, just 8 horses running, and then who comes in third, I guess, or first, second, and third was the example that I used. So we went back to the horses that we were talking about this week. So order does not matter with these ones. And again, your formula for this one is just that factorial piece from your binomial theorem. Just so it shouldn't be too scary. And then the notation for this one, combination gets its own little notation, and it's n choose r. And again, n is number of objects, and r is number of objects that you are selecting. And this works just the same as the binomial theorem little factorial piece on the calculator. It's math prob number 3. We went over that yesterday, so hopefully you guys remember that one. And I think that's it, unless Miss Lastly has anything to add.
Nope. The only thing, just remember, guys, if it says something about, if you see the word order in the problem, it's probably a permutation. So like the one I can think of from the checkpoint that confused a couple people was, how can you make a batting order? A batting order, the order of the players is important. If you're just selecting people off of a team to like go get water, then the order you select those people doesn't matter. So just be careful. Another one that kind of tripped people up, and I know it's because it had the word combination in the problem, but if you're setting a combination on a lock, that's a permutation. So just because the word combination is in the problem doesn't mean it's a combination problem, right? You just have to kind of think about that one. It's unfortunate that words in the English language have more than one meaning to them, but the word combination can mean more than one thing. So if you're setting a combination on something, like a password, then the order you put the letters in is important, or the order you put the numbers in is important. So don't get tricked with those ones. Just think logically. Remember, the word combination doesn't necessarily mean it's a combination math problem. So just be careful. Read them pretty, slowly. Look for keywords. If you see the word order, it's probably a permutation problem. But yeah, you guys overall did really good on that last week's checkpoint. So I'm not too concerned that you guys are going to have a hard time on that during our checkpoint tomorrow. But just, read carefully. Don't try and overthink things. If there doesn't seem to be a difference between like the different situations, it's probably a combination problem. Like the vacation one, it was like, we want to go to 7 different countries, but we can only go to 4, or something like that. Well, it doesn't make there seem like there's anything different with the vacations, right? You're just going to 4 places out of 7. That's just a combination problem because the order you take those vacations doesn't matter. So just be careful. yeah, but overall, you guys did really good last week. So I believe you'll do pretty good on this checkpoint.
Cool.
Yeah. Yeah, so that is it for today. And we will see you later on today during our live stream. Bye, guys.